This quote that you're reading from Bill Harmon from many decades ago is becoming a reality. And what I want to, the reason I've given this to you is that this is not just society, but it's the science that we all work on, we practice it, we love it, and that's, for us, what's changing the most. So while our society is shifting, our science is also shifting into something new. So this is a challenge that we're facing, and some of you may feel some anticipation about this challenge, like you don't like it. I hope most of you are looking forward to it, and not only to respond to it, but to participate in it and to help create it. And that's what I want to address today. Before I get around to talking about my modest contribution to a new science, I'd like to spend just a few minutes talking about the what and the why and the how this all came about. This will help set a common ground so that we're able, I hope, to assess innovations and ideas that come up that for how we're going to respond to this challenge. Maybe we can assess it a little better if we have this common ground. Okay? So the first question is, how did this, that is, why is it we're concerned about this difference between these advances that are happening in science that are sometimes very confusing? It's happening mainly because some serious contradictions have arisen between scientific understanding of the real world and the observations, experimental and empirical findings that have been come up, as you just heard about very adequately from Henry Bauer. Here's a list, just flash through it quickly. You know most of it, just to refresh your memory on why these contradictions have arisen and we're being forced to respond to them. Okay? I'm not going to read them all, but it's very clear that the mind is involved in most of these, a mind that's been excluded from science for a long time. And it's now playing a big part in the difficulties that have been arising. Now, this is really intolerable for a science that's supposed to be representing to the world what reality is all about, right? It's been very adequately summarized in a recent manifesto that came out of, that's been published in Explore and in other places. It's passing around, so look it up if you haven't seen it. For the details, check out Larry Dossey's book called One Mind, where he spells out all the evidence pretty well. But where did these contradictions come from in the first place? How come they're with us? Well, they came from a set of fundamental and underlying assumptions. This is perhaps a fact more than a cause, but there they are, and we're living with them. I can summarize these assumptions this way, that we are assuming, there are assumptions in our methodology, good old objectivity, the fact that we investigate things only based on the human senses, rational analysis, measurability, repeatability, and of course, reductionism. And this means that the scope that we have of the reality that we're supposed to be investigating is limited to just what's material, objective, what we can objectively observe through our human senses. These assumptions, to remind you something you heard more than once, are not derived empirically and then proven, but were adopted pragmatically as it seemed necessary in the evolution of science. Okay, and now, what are they? They're dogma, right? They've never been really established. We're just assuming them. Assumptions are fine, you know. We have to live with them, but you have to remember that you made them. And this is part of the problem. Once you forget them, you start interpreting them as dogma. But the main thing is that there's no place with these assumptions, there's no place for the human mind and what's going on in this reality that we're supposed to be exploring. So if we're up to improving science, to extending it somehow, it's eventually going to have to do something with these assumptions, modify, replace, or drop them entirely. And well, okay, that's our challenge. How can we possibly extend the science that's operating in our world and do something about it? Well, there have been several alternatives proposed, most of them very broad, and they're not really well advanced or proven or established. It's going to take quite a while to find the evidence that these different theories, as I've listed here, are really the things that we want. And in the meantime, I have something else. Let's notice, first of all, that there are two steps in the great scientific process. One we can call discovery, and the second is validation. Now, this is not a clean split because there's some feedback going from validation back to discovery and so on. But it will serve our present purpose. The thing is that science is really good at validating things. That's our biggest strength. It may not be perfect, but it's our biggest strength. But discovery doesn't have the same criteria. We can discover new things in the form of new views, ideas, new perceptions, even hypotheses, without ever going through the rigor of science. And some kid in his basement 16-year-old kid in his basement can make a great discovery, you know, and he relies upon science to tell him if he got it right or not. And mostly, of course, he didn't, but every once in a while it happens. But this discovery process is really wonderful. I mean, many scientific discoveries have been made just this funny way, you know, dreams even. And I think we have to respect this. And to most scientists, this is a taboo, you know. You don't inquire where your ideas came from. That's psychology or something, you know. But for heaven's sakes, it's the key to what we're doing, I think. So, proposal, we can postpone some of this validation until a little later, okay? And but we do need to explore alternative ways of generating new knowledge, okay? And why not use some of these anomalistic mental phenomena, mental capacities that we are running across to actually generate the new ideas, right? Okay? There are several of these anomalies. Here's another display of several of them, and you will recognize a few that you perhaps have had yourselves and so on. But they differ widely in how they can be used, their accuracy and the control you have over them, their information bandwidth that they offer, and so on. But the common thread among them is this direct knowing or innate knowing process. The Greeks called it nous, meaning that's the root of the word gnosis and noetics. You know, knowledge is already there, and that's the core of the discovery process. You don't have to generate it over again, it's already there. Well, that's pretty incredible. We can rightly call this intuition, meaning as a human faculty, it's the direct reception of information, new information, not even knowledge, without the uses of the senses or rationality or memory. We all have the capacity to pick up this information directly without these other faculties, okay? Does it really exist? Well, it's hard to believe that it doesn't. Intuition has a long history. We're all familiar with it in limited ways, in a sense. But it has a big credibility gap for many scientists, as I just claimed. And of course, in the ways that we're familiar with using intuition, it's terribly unreliable. We can't trust it for much of anything, even for good ideas. But as far as we can tell, the capacity is with everybody and is virtually universal. The source is unknown, but that doesn't matter. There's a lot of unexplained things from aspirin on down in scientific and medical world that we can't explain, but that doesn't keep us from using them. And occasionally it's very, very accurate. So the question is there some way that we might use this intuitive faculty in a useful way to enhance the science that we're trying to extend? If we do, it's got to be systematic, of course. It's got to be available to virtually anybody. It's got to be have a large information bandwidth, not just an isolated discovery like is often done in the early remote viewing work. And there are probably other conditions that we don't know yet. So how about it? Should we take a look at this? I offer this as a possible approach. Back in the late 70s, I formed the Center for Applied Intuition to look into these matters. The purpose was to try to understand the intuitive process well enough that we could apply it to the solution of practical problems, not only scientific, but other types of problems as well, and to demonstrate this if possible. We did a lot of things, research and public presentations and education, publications, or radio program even, and put on several conferences about the intuition in psychotherapy and education, for example. But the goal was to develop a method of intuitive inquiry and apply it to the solution of several practical problems. Well, we did this and worked out an inquiry procedure in which you define your problem carefully, work out questions, and push them across to people that were very good with their intuition. That is, we've all got it, but they've made the effort to develop it so that it can be used on demand. And go through studies. We used a consensual method in which we work from anywhere from 3 to 10 different intuitives, inquire independently what they can tell us, and then form a consensus. What's common between them, okay? I call it intuitive consensus. No, there was no attempt at validation or prediction at this time. They were just trying to see what's possible, you see? The validation would come much later. Maybe we wouldn't even do it at all. It turned out to come like 2 or 3 decades later. Well, there were 2 classes of applications. One is that the verifiable applications where we could go out and actually find evidence of what the intuitives told us is correct. There are 4 of them that are listed here. And the other class is the not validatable by any means we know, or not very much so, but they're still useful in different ways for ideas, for inspiration, and so forth. And we looked at both of these. The main one we did, or rather the one that had the strongest results, were in the area of earthquake prediction. Of course, this is a big problem for the world, and there are no solutions available to it. We can do very short-term prediction of a hour or two. We can do very long-term prediction to tell you which buildings ought to be strong. But in between, predictions of a week to a month are not available at all because of precursors that we would use to do the detection. The physical precursors are not known. There's a few of them that are listed here on the right-hand side that were being explored, but they hardly got off the ground. Seismology was at a standstill in those days, back in 1975 to 78. Nothing was happening. Funding was very low, and they were fussing around with squeezing rocks and seeing what would happen. And here's the kind of consensus that came up. It says that there's built-up stress, of course. We knew that, but there are various radiated inner Earth energies that are coming out from the Earth. That's part of the precursory scene, the triggering scene. But there's also external radiations that are coming from outer space, upper atmosphere, and shifts in the ionosphere. There's electromagnetic energies going around. This was unheard of in seismology, even in geophysics. So this is pretty astounding, that this kind of information. And of course, we didn't believe it either when it first came. Even stuff from the planets, which are causing solar activity inside the sun, and this affects all the radiations from the sun, the geomagnetic field of the Earth, and so forth. This is pretty far out stuff. These precursors that are listed on the right. Well, in the mid-'80s, the first validations started coming in when satellites went up. They found the heat coming from the Earth. They found ionospheric shifts just before major earthquakes. And they found this electromagnetic energies going around. So that was pretty encouraging. So in 2010, we collected all the geophysical literature that we can that seemed relevant, and everything was verified, everything, to one degree or another, but mostly very much. The first three were very well verified. Others were just a little, but on the whole, the project was extremely successful. So this is an example I offer of what can be done. Satellites are now in orbit checking these things out. So the conclusion is that intuitive inquiry is a viable and a highly effective means for obtaining totally new information, even highly technical information, okay? We bypassed the usual process of science in doing this. Well, there are other applications, of course, like the ones on the right, studying infant death and so on, finding missing people. The necessary conditions for this to work are the intuitives have to be good, that is checked out. You've got to prepare the questions carefully and pose them carefully so that you don't lead and so forth, lead the intuitive. You should have a serious intention of applying it, and the whole process needs to be harmless in some sense, even after it's all finished. And this has a lot of social implications, not only for society, but also for SSE. We're really already on the forefront of this, you know? We're already multidisciplinary. We're not afraid of novelty. And we are inclined to move forward, not to stick where we are. There's a number of actions that SSE can take. I think they're pretty obvious. For individuals, though, there's a big difference. The intuition that we're using is a way of transcending strong belief in things into knowledge. This is a transition from belief to knowledge, okay? This is the kind of thing that mystics do, you know? And the process is a highly intuitive one, even for the mystics. You can do a further stage, which is a kind of a deep immersion with an identity with the problem that you're working on, right? You've heard about this sort of thing. It sounds pretty crazy, but it's true. Mystics don't think, they don't believe, they know, you know? And this is what intuition is really all about. So intuition has the potential. So I'll make this claim, my last statement, Bill. As scientists explore further into the free and open use of their intuitive faculties, they'll have to gain access to they will gain access to the immense resources of the human mind. And this, I claim, is what this is all about. It's why we're doing what we're doing. And we're going to discover that the mind has a central place in all of reality, which has been proposed by several people. So we enhance the scientists, we enhance science. Okay, thank you very much.
Thanks, Bill.
Have you looked at the work, for example, of the Association for Research and Enlightenment, the Edgar Cayce Foundation, actually trying to evaluate screen intuitives, quantify it, measure, and all that sort of thing?
I'm grateful to Edgar Cayce and the Edgar Cayce Foundation for getting me started, as he and they have done for many people. I think we've gone quite a bit farther than what either Cayce was able to do with the expert intuitives who are now operating, to point to another extreme. And I think the information that we can get is much more reliable than Cayce's. This is not a criticism of him, really. He was a pioneer, and we have to appreciate our pioneers. But you know, most of his predictions were wrong and things like that. But golly, what a tremendous contribution he made to Western culture.
Thanks, Bill.
Okay.